Welcome back to the Funny Math Teacher. Remember, expectations are to use twice this video's length to take notes and wonder, and these notes are for your future self. Today we're doing something interesting with these notes, so this lesson and the next one are definitely tied together, and it's a really quick unit for exponents. So today we're going to be writing exponential expressions in expanded form, a lot of EXPs there, exponential expressions in expanded form, and we're going to be taking notes in a booklet. It's going to be fun. So I know it's going to be a little wonky just because I'm used to doing this with actual people in front of me instead of virtual over the screen. So we'll see how we can make that happen. So this unit will be 2 pages long exponents booklet of rules and perfect squares and cubes, which you'll need an extra piece of paper to make the booklet. So go get 1 piece of paper and then practice simplifying exponents using our expanded form will be page 20, and that will be our second video. All right, so going to page 19, there we go. So I'm basing this off of my cheat sheet key. Okay, so make a pocket if you want, or we can just tape the back page of the booklet into your notes. Both of those will work, but the goal is that it's nice and easy to, I need to remove this, but if you have an actual piece of paper, then we can always tape, the back will be blank, so we can tape that last page to it, and then it's just permanently in your notes. That works too. We are going to write some stuff below it that's not here right now, but that's where we're headed. Okay, and I'm going to be using a piece of notebook paper for my booklet. Hopefully that means that you can see the lines and that'll help you orient what I'm doing better than just a piece of blank white printer paper. So we're going to start with exponents first. Like, what is an exponent if you've never seen one before? So if I have 3 squared, this 3 is going to be my base, the 2 is the exponent, and we are going to write more of this in our booklet, but I wanted to do a little tiny intro. So 3 squared means 3 multiplied by 3, which is 9. Writing the 3 times 3 with a dot in between, or you could use parentheses if you want, or you could use a little asterisk star. We're not going to use x because x is reserved now for a variable, but this is the expanded form. It's taking the exponent out and actually applying it. So we have common squares. So what would 1 squared be? 1 times 1. 1. All right, so now I'm going to write these really fast. I want you to pause the video and see if you can write down as many perfect squares, because that's what these are called. They're perfect squares. They're nice whole numbers, as you can. Equals 36. 7 squared is 49. 81. 12 squared, 144 is called a gross amount, by the way. 169, which is then fun because 14 squared is 196. 225. 256, yeah. I drew. Is 17 squared 289? I think. I don't remember what 18 squared is. I'm going to look that one up. Come on. 18 times 18. There we go. 324. 19 squared, I don't remember. 20 squared is 400, and we're going to stop at 20. 361. I knew it was a 3, but that doesn't really help you much. And then 1 cubed will be 1, because that's 1 times 1 times 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed will be 27. 4 cubed will be 64, and I'm going to stop there. If you want to keep going, you're welcome to. I've never gone anywhere above, what was 8 cubed? Have I done 8 cubed before in a problem? Yeah, I guess I have. But I haven't really gone beyond 8, really. Well, if you do, then you have a calculator by that time. So these I would definitely memorize, or at least you're going to use them often enough. I would make flashcards, just practice them a lot, and we'll get going. So we're going to make the booklet. So you have a piece of paper. To make the booklet, we're going to fold it hot dog style, so lengthwise. Okay. Open it back up. Then we're going to fold it hamburger, so widthwise. We're going to make 8s. That's our goal, is to make 8s. That was And the more exact you are, the better this will turn out with where your creases are, but I'm not sure I'm exact here. Okay, so once you have fourths, we're going to take each of these edges and we're going to fold them into the center to make our others. That way our folds are where we want them. It just is a little simpler to fold. So I'm going to fold my left and right sides into the middle on that main crease there. Otherwise our folds will be not quite the directions we want them to. And we'll fold this side into the middle, and you should have 8 vertical boxes. Or I guess horizontal if you hold it up. So I'm going to have 8 horizontal boxes. Alright, I'm going to fold it in hamburger style again. And now you can either use scissors or you can tear it because you have enough crease. As long as you've creased it really well, it'll tear really well. But we're only tearing from the top. Remember, this is where the fold is. The top is where the fold is. If you go the other way, it's not going to help you. So from the fold, we're only tearing down halfway. You're stopping at this middle piece. If you don't stop, you'll just have torn paper in half. Okay? So I like to take this piece and crease it a little bit more. And then you can start the tear. And then you can fold it up and tear. But remember, we're only going to that middle crease and stopping, okay? So you have a piece of torn paper, but not all the way. I know with some paper it tears easy. Open it back up, so now you have this mouth in the middle, you know? Fold it hot dog wise. And now this is why we have our creases the way we have them. You're gonna push them in, and this is where the magic happens. I learned this from McDonald's Happy Meal, by the way. Isn't it cool? Okay. So you've then clenched them together and just fold it all together into a book. It's so amazing! I love it. The more exact you are, the less you have like extra stuff that you have to push back down because sometimes it kind of overdoes it. But we have a book. We have a book. Whoop. So I did the line paper just so you can see the definition. If it was printer paper, you wouldn't see much. But we're not really going to use lines on this. I actually use scratch paper so you can see the back side of my original paper on this. My maiden name was Evans. And then we're going to write. So we're going to write some stuff. We're going to write some more stuff. We're going to use some examples. And then the back will be blank so you can tape this down if you want. So on the front, call it what your name is. So my name is now Mrs. O. This is my book of exponents. I'm going to go a little fast because we already are 8 minutes. Okay, so first page. I'm going to use a pen on this. All right, so first page. This is called Parts of a Power. So I have 2 to the 4th. That's going to be the same as saying 2 times 2 times 2 times 2, which is going to equal 16. We call this 2 the base. So the base is what number we're multiplying. The 4 is called our exponent, and that's the number of times we multiply it. So it's not 2 and 4 more times. It is literally 4 2's, all being multiplied together. So the exponent tells how many times the base is multiplied together. All right, there we go. So it literally is 4 2's all being multiplied. It is not 4 more 2's. It is only straight 4 2's. Okay. Second page. If you write just the number 3, this actually is the same as saying 3 to the invisible first power, which if you've been doing some of my Curikey activity playlists in our first unit, you'll have noticed that I've mentioned those invisible ones with our like terms before when we combined them. So, if a constant or variable does not have a written exponent, it is automatically an exponent of 1. And I'm going to put an extra example down here. If you have x, y squared, z. Notice these are all being multiplied together. X is being multiplied by y squared, is being multiplied by z. This is the same as saying there's 1x being multiplied by 2y's being multiplied by 1z. So there are those invisible ones. If I wanted to put this in expanded form, it would be x times y times z. And now notice in expanded form, all of our exponents are 1. So that's how you know it's expanded, because you have no other higher number other than 1 as your exponent. You all have just exponents of 1. All right, next page. I'm going to write across the top for a reminder. So remember, only use these rules with like bases. If they do not have like bases, they are not considered enough like terms to combine and simplify. All right, so like bases is key. So our first one will be power to a power. Now, exponents are also called powers. That's where that word power is coming from, is an exponent. So this is 3 to the second power. All right. Oh, and we have special words. So squared is the power of 2. Cubed is the power of 3. If you want to go cool, you could say quartic to the 4th power. After that, just say the 5th power, the nth power, whatever your number is. After that, it's just nth power. Okay, so power to a power. If I take x squared and I cube x squared, that is the same as saying x squared times x squared multiplied by x squared. I have 3 of the x squareds. So how many x's is this total? Well, I have 2 for those, 2 for these, 2 for that. So I'm going to have x to the 6th total. Both of these are getting to the expanded form here. This is your expanded form, all of the exponent of 1. All right, multiply. So instead of power to a power, we took 2 to the 3rd power. I'm going to take x squared, I'm going to multiply it by x cubed, which means I'm going to have 2 x's being multiplied by 3 more. How many x's in total are being multiplied together? 5. So I have 1x being multiplied 5 times in total, so that means my base is x and my exponent is 5. All right, and then we're going to divide. I know I'm rushing, but you can always pause and go back. I'm trying to keep this as short as possible so you can maximize your pausing time without having to just jump around stuff. So for division, remember fractions mean division, so I'm going to have 9 x's in my numerator. And how many x's in my denominator? And now we're going to do some division. What is x divided by x? 1. So these make 1. I'm going to draw the ones just because these are notes. I'm going to draw the ones so we see them. X divided by x, 1. X divided by x, 1. Well, what's 1 times 1 times 1? 1. My whole denominator disappears. It's not gone, it's just 1, so I don't have to write it because there's a bunch of invisible 1s in life. And how many x's are left in my numerator? There are 6 being multiplied together, so it's going to be x to the 6th power. All right, and you could put this over 1 if you want to put the 1, but you don't have to. All right, so your keys here are to look for patterns, because there are so many patterns. In these 3 rules, there are so many patterns. And the next one is to keep numerators and denominators where they belong, which is going to be key on the next pages. And I just want to also say something. What was I going to say? I don't remember, so it's not worth it. Maybe I'll remember. Okay, last 2 pages. Negative exponents. All right, so negative exponents is just this one page and we'll write something else on the last page. So, to turn a negative, oh, that's what I was going to say. Notice that these are all the same base. X is the same base, X and X are the same base, X and X are the same base. If they were different bases, if this was y to the 9th over x cubed, I couldn't have done anything. That would have been as simplified as possible. So they have to be the same base, otherwise you can't divide. Because x divided by x is 1, but y divided by x would not be 1. Okay, to turn a negative exponent into a positive exponent, cross the line, that's that fraction bar, cross the line because we're going to be dividing, and change the sign of the exponent. Exclamation point, because why not? So if I have an example, x to the negative 2 power over y to the negative 3 power, so I'm dividing. And it's really nice to put this in a fraction. So even if I had a singular one, which I'll show you an example, we're going to have a denominator of 1. So this negative tells me I need to cross the line and put it in the denominator and change the sign. So this is the same as putting x squared in the denominator. But I have another negative, which means y is going to go up to the numerator because it has to cross the line as well. And now I'm going to have positive, or y to the positive 3rd power. That's my final answer. Okay, so a negative doesn't simplify anything else except moving numerators to denominators and denominators to numerators. So make sure they're in the right spots. Another example would be, what if I just had 2 to the negative 4th? Think about this as 2 to the negative 4th over 1, because it is. It's a 1 in the denominator. If you don't see it, it's a 1 in the denominator, which means I'm going to take this, I'm going to move it down, base and exponent. I'm going to end up with 2 to the positive 4th, which we actually know, because what's 2 times 2 times 2 times 2? 16. So this is the same thing as 1/16. I can't simplify this one since there are variables that I don't know what they represent, but I do know what 2 times 2 times 2 times 2 is, because that's a constant. All right, last page. And yeah, I'm not going to do my fun thing because we have too much. We're already over. So if you take anything to the 0 power, what does it equal? 1. It is always 1. Math would break down if we did not have this. Anything to the 0 power, or 0 as the exponent, is equal to 1. And I'm going to draw a big 0 around this, okay? So if I take x squared, y cubed, z to the 5th, all to the 0 power, what does that equal? Looks real complicated, but it's just 1. If I take 6 to the 0, it is 1. All right? Anything to the 0 power is 1. And we're good to go. You're golden for your booklet. You can tape it in here, and now you can fold it over, and you can just flip through it anytime you want. And going back to our comprehension questions, pause it, figure out what patterns have you seen, because there are a bunch in there. All right, thank you for watching and have a great day.